Welcome to Astronomy Daily, your cosmic connection to the stars and beyond. I'm Anna, bringing you the latest developments in space exploration and astronomical discoveries right to your ears. Today's episode is packed with fascinating stories that showcase both the mysteries of our universe and humanity's incredible technological ingenuity in uncovering them. We'll be exploring several breaking stories that highlight just how dynamic our solar system truly is. We'll start by delving into a new gravity study that finally helps explain why the two sides of our moon look so dramatically different, a question that has puzzled scientists for decades. The research reveals fascinating asymmetries deep within the lunar interior that have shaped its distinctive appearance. Then, we'll head down under to Australia, where an aerospace firm was preparing for a historic rocket launch that would have been the first Australian-made rocket to reach orbit from Australian soil. We'll look at what happened with this milestone attempt and what it means for the growing global space industry. Next, we'll travel to the very edge of our solar system, where NASA engineers have achieved what many would consider impossible: reviving thrusters on the Voyager 1 spacecraft that had been deemed unusable since 2004. This remarkable feat of remote engineering shows just how resourceful our space teams can be, especially when working with a spacecraft that's now over 15 billion miles from Earth. We'll also examine fascinating new findings about Venus that suggest our nearest planetary neighbor may be more geologically active than previously thought. Data from NASA's Magellan mission has revealed evidence of ongoing tectonic processes that reshape our understanding of this enigmatic world. Finally, we'll look at a historic first on Mars, where the Perseverance rover has captured an image that no human has ever seen before: a visible aurora on the red planet. This subtle green glow gives us a preview of what future Martian explorers might witness in the night sky. These stories remind us that our solar system is not a static place, but an ever-changing, dynamic environment full of ongoing processes and unexpected discoveries. They also highlight the incredible technological achievements that allow us to explore these distant worlds from right here on Earth. So settle in as we journey across the cosmos, exploring the latest findings that continue to expand our understanding of the universe we call home. Let's get things underway. One of the most enduring mysteries about our closest celestial neighbor has been why the moon's near side, the face we see from Earth, looks so dramatically different from its far side. Now, an exhaustive examination of lunar gravity using data from NASA's Grail mission is offering compelling new evidence to explain this lunar dichotomy. The research team discovered that the moon's near side flexes slightly more than the far side during its elliptical orbit around Earth. This difference in tidal deformation, caused by Earth's gravitational pull, indicates significant structural differences between the two sides of the lunar interior, particularly in the mantle layer. Our study shows that the moon's interior is not uniform, explains Ryan Park, lead author of the study published in the journal Nature. The side facing Earth, the near side, is warmer and more geologically active deep down than the far side. This temperature difference is substantial. Researchers estimate that the near side mantle averages between 180 to 360 degrees Fahrenheit, hotter than the far side mantle. This thermal difference is likely sustained by the radioactive decay of elements like thorium and titanium, which appear to have accumulated on the near side over billions of years. The findings help explain the stark visual contrast between the two lunar hemispheres. If you've ever looked up at the moon, you've noticed that the near side is dominated by vast, dark plains called mare, formed when molten rock cooled and solidified billions of years ago. In contrast, the far side has a much more rugged, mountainous terrain with very few of these plains. Scientists have long hypothesized that intense volcanism on the near side caused radioactive, heat-generating elements to accumulate in the mantle beneath this hemisphere, driving these surface differences. The new Grail data provides the strongest evidence yet supporting this theory. The researchers devoted years to analyzing data from the twin Grail spacecraft, Ebb and Flow, which orbited the moon from December 2011 to December 2012. Their work has resulted in what Park describes as the most detailed and accurate gravitational map of the moon to date. Beyond solving this lunar mystery, the enhanced gravity map has practical applications. It will be crucial for developing lunar positioning, navigation, and timing systems, essential tools for future lunar exploration missions. By improving our understanding of the moon's gravity field, the research contributes to establishing a precise lunar reference frame that will enable safer and more reliable navigation for spacecraft and surface operations. This asymmetry in the moon's interior structure also deepens our appreciation of our celestial companion's importance to Earth. The moon stabilizes our planet's rotation and generates ocean tides that influence countless natural systems and daily rhythms on our world. What's particularly exciting is that the gravitational analysis techniques used in this study could potentially be applied to other bodies in our solar system, such as Saturn's moon Enceladus and Jupiter's moon Ganymede, both considered prime candidates in the search for potential life beyond Earth. Next in today's story lineup, an Australian aerospace firm has been forced to delay what would have been a historic rocket launch from Australian soil. Gilmour Space Technologies had planned to conduct the first test launch of their 3-stage Eris rocket yesterday, but had to postpone after encountering a ground system glitch during pre-launch operations. The company's communications chief, Michelle Gilmour, explained that the issue was with an external power system we used during system checks. The technical team identified the fix, but ran out of time to implement it and fuel the rocket within the day's launch window. They're now targeting today for the rescheduled launch attempt. The 23-meter, 75-foot Eris rocket is poised to take off from a spaceport near Bowen, a coastal township approximately 1,000 kilometers north of Brisbane. If successful, it would mark a significant milestone as the first Australian-made rocket to achieve an orbital launch from Australian soil. While the maiden flight is primarily a test, the rocket isn't traveling empty. In a quintessentially Australian touch, it will be carrying a jar of Vegemite, the iconic Australian toast spread, as its payload. CEO Adam Gilmour has been candid about managing expectations for this first flight. If it orbits Earth, I would probably have a heart attack, actually, because I'll be so surprised but deliriously happy, he told reporters. We're going to be happy if it gets off the pad. 10, 20, 30 seconds of flight time, fantastic. So orbit is just not in the realm of my belief right now, even though it's theoretically possible. The Eris rocket is designed to eventually carry small satellites weighing between 100 and 200 kilograms into low Earth orbit. Weighing 30 tons when fully fueled, it uses a hybrid propulsion system combining solid, inert fuel with a liquid oxidizer. Gilmour Space Technologies has backing from private investors including venture capital group Blackbird and pension fund Hesta. The company, which employs 230 people, has ambitious plans to commence commercial launches by late 2026 or early 2027. Here's wishing them all the best with the next attempt. Now here's a story that truly showcases the incredible ingenuity of NASA's engineering team. In what can only be described as a remarkable feat of remote problem solving, engineers at NASA's Jet Propulsion Laboratory have successfully revived a set of thrusters aboard Voyager 1 that had been considered completely inoperable since 2004. This achievement is particularly impressive when you consider that Voyager 1 is currently hurtling through interstellar space at approximately 35,000 miles per hour, over 15 billion miles from Earth. That's so far away that radio signals take more than 23 hours to travel between the spacecraft and our planet. The thruster revival was critically timed. Engineers needed to fix these systems before May 4th, when the Deep Space Network's 230-foot-wide antenna in Canberra, Australia, the only dish powerful enough to send commands to the distant Voyagers, went offline for extensive upgrades that will last until February 2026, with only brief operational windows in August and December. Why was this fix so urgent? The Voyager spacecraft rely on small thrusters to maintain their orientation, keeping their antennas pointed at Earth so they can continue sending back data and receiving commands. The primary set of thrusters currently in use on Voyager 1 have been experiencing fuel tube clogging due to residue buildup, which could cause them to fail completely as early as this northern fall. The situation was complicated by the fact that the backup thrusters had stopped working back in 2004 when two small internal heaters lost power. At that time, engineers determined the heaters were likely unfixable and switched to other backup systems. After all, who could have predicted Voyager would still be operational 2 decades later? After revisiting the 2004 thruster failure, The team suspected that an unexpected circuit disturbance had essentially flipped a switch to the wrong position. If they could turn the switch back, the heaters might work again. This solution required precision timing and careful planning. If the spacecraft's star tracker drifted too far from its guide star during the fix, the dormant thrusters would automatically fire without their heaters, potentially causing a small explosion. On March 20th, after sending their commands and waiting anxiously through the 23-hour signal delay, the team witnessed the temperature of the thruster heaters rise dramatically, confirming their success. As mission propulsion lead Todd Barber described it, "It was such a glorious moment. Team morale was very high that day. These thrusters were considered dead. It was yet another miracle, save for Voyager." Launched in 1977, both Voyager 1 and its twin Voyager 2 continue to push the boundaries of space exploration as the only spacecraft to have ever sent back data from interstellar space, the region beyond our solar system's protective bubble. This latest engineering triumph ensures that this incredible scientific journey can continue even longer. Let's move on now to some news from one of our celestial neighbors. Our understanding of Venus, Earth's so-called twin planet, continues to evolve as scientists uncover evidence that it may be more geologically active than previously thought. New research based on data gathered over 30 years ago by NASA's Magellan mission has revealed fascinating insights about vast, quasi-circular features on Venus called coronae, which suggest ongoing tectonic activity beneath the planet's surface. Unlike Earth with its shifting tectonic plates, Venus doesn't have plate tectonics as we know it. However, this doesn't mean Venus is geologically dead. The new study published in Science Advances indicates that its surface is still being deformed by molten material rising from below. Coronae are enormous structures, ranging from dozens to hundreds of miles across, where plumes of hot, buoyant material from Venus's mantle are thought to push against the lithosphere, the planet's crust and uppermost mantle layer. These features typically appear as oval structures surrounded by concentric fracture systems, and hundreds of them have been identified across Venus. What makes this research particularly exciting is that it suggests multiple ongoing processes are actively shaping these coronae. By combining gravity and topography data from Magellan and developing sophisticated three-dimensional geodynamic models, researchers were able to identify 52 coronae out of the 75 studied that appear to have buoyant mantle material beneath them, likely driving tectonic processes. The team identified several different mechanisms, potentially at work. In some coronae, a Venus-specific type of subduction may be occurring. As hot rock pushes upward from the mantle, surface material rises and spreads outward, eventually colliding with surrounding material and pushing it downward into the mantle. Another process called lithospheric dripping might also be present, where dense accumulations of cooler material sink from the lithosphere into the hot mantle below. Lead researcher Gail Cascioli, who is part of NASA's forthcoming Veritas mission to Venus, noted that these features might provide a unique window into Earth's past. Coronae are not found on Earth today. However, they may have existed when our planet was young and before plate tectonics had been established, he explained. This work is especially significant as it represents yet another instance where scientists are finding Venus exhibits more Earth-like geologic processes than originally thought. Just recently, researchers were able to identify erupting volcanoes and vast lava flows in radar images from Magellan, providing direct evidence of volcanic activity. While these discoveries are groundbreaking, scientists will need even higher resolution data to fully understand the tectonic processes driving corona formation. That's where NASA's upcoming Veritas mission comes in. Scheduled to launch no earlier than 2031, Veritas will create detailed three-dimensional global maps of Venus and measure its gravitational field to determine the structure of the planet's interior at unprecedented resolution, potentially revolutionizing our understanding of Venus and what it might tell us about Earth's early history. Next, let's head off to our other near neighbor and one of our favorite planets. In a groundbreaking astronomical first, NASA's Perseverance rover has captured an image of a visible aurora on Mars. On March 18, 2024, the rover observed what scientists describe as a subtle green glow hanging low in the Martian sky, wreathing the horizon in every direction. This marks not only the first sighting of a visible Martian aurora, but also the first observation of any aurora from the surface of a planet other than Earth. Until now, auroras had been spotted on Mercury, Jupiter, and every other non-Earth planet in our solar system, but only from orbit. On Mars specifically, scientists had only detected auroral wavelengths of light that are invisible to the naked eye using specialized instruments. This new observation answers a long-standing question about what future human explorers might witness in the Martian night sky. According to Roger Wiens, a planetary scientist at Purdue University, future astronauts would see a dull or dim green glow with their own eyes. The image from Perseverance appears somewhat fuzzy compared to the spectacular aurora displays we're accustomed to seeing from Earth, and for good reason. The rover's cameras aren't optimized for night photography, performing with sensitivity roughly comparable to human eyes. Another factor contributing to the aurora's different appearance is Mars's unique magnetic environment. Unlike Earth with its global magnetic field that concentrates auroras near the poles, Mars has a patchy, magnetized crust. This means auroras can appear all over the planet rather than being confined to polar regions, but they tend to be comparatively dim. Scientists believe this particular aurora was triggered by a coronal mass ejection, a large cloud of plasma and magnetic fields blasted from the sun into space. The Perseverance team was alerted to this solar event days in advance, allowing them to prepare the rover to capture this historic image. Interestingly, while Perseverance is located near Mars's equator, researchers suggest that observing auroras from Mars's southern hemisphere might yield even more spectacular results. That region contains the most magnetized part of the planet, potentially producing stronger auroral displays. This discovery adds another fascinating chapter to our understanding of Mars and provides a glimpse of the ethereal experiences awaiting future human explorers who might one day stand on the red planet's surface, gazing up at a glowing green Martian sky. And that brings us to the end of today's cosmic journey through the latest space news. From the mysterious asymmetry of our moon to engineering marvels on Voyager 1, tectonic activity on Venus, delayed rocket launches in Australia, and the first ever image of a Martian aurora, the universe continues to surprise and inspire us with each new discovery. I'm Anna, your host here on Astronomy Daily, bringing you the stories that connect us to the vast cosmos beyond our atmosphere. Whether you're a seasoned astronomer or simply curious about what lies beyond our blue marble, I hope today's episode has sparked your imagination and deepened your appreciation for the wonders of space exploration. If you've enjoyed today's show, please visit our website at astronomydaily.io, where you can sign up for our free daily newsletter and stay informed about breaking astronomy news. While you're there, you can also browse through all our back episodes to catch up on any cosmic stories you might have missed. Don't forget to subscribe to Astronomy Daily on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts to ensure you never miss an episode. Until next time, keep looking up. The universe is putting on quite a show.